Okay, today we are going to learn about the last type of combinatorial problem, and that involves combinations. Remember, we talked about permutations and variations, and in both cases, the order mattered. The only difference was that in case of variations, we first picked only k elements and ordered them, so not all elements were involved. I'm talking about those cases when there was no repetition. Now we are going to talk about a third type of problem where there is no repetition and you have again n elements and you want to pick k, but unlike before, the order doesn't matter. Typical problem involves distributing or giving a handful of cards to someone from a deck of cards. You can see here 54 French cards made up of 4 suits, the spades, the diamonds, the clubs, and the hearts, each having 13 possible values, the numbers from 2 to 10, and the 4 figure cards, Jack, Queen, King, and Ace. So from these 52 cards, if I considered the order when I give you 5 cards, then it would be a variation problem, and you all know how to solve it. The first card could be any of the 52 cards, then the next one I can get is any of the next 51, then I can only choose from 50, 49, and finally 48 cards, and that would be the 5-element variation of my cards. However, in real life, when you get a certain number of cards to play with, order rarely matters. So the question is, how many ways can I get 5 cards out of this pack of 52 cards? 52 cards, so that order doesn't matter. Order doesn't matter. That's our problem. And the problem is solved by first thinking of it as if the order mattered. So we write up this multiplication, this product, and then we think, every time I have the same 5 cards and the only difference is that they are differently ordered, I'm still talking about the same 5 cards in my hand. So basically, the idea is similar to what we did with permutations with repetition, that you have to divide this number by the number how many times 5 cards can be ordered, because those orderings all result in the same set of 5 cards. 5 cards can be ordered in 5 factorial way, so your answer to the original question, how many ways can I get 5 cards out of 52 cards, so that order doesn't matter, is going to be this number. I'm not going to calculate it. Instead, I'm going to show you how many different ways can you write this up using factorials. First way is to say that in the numerator, I write down 52 factorials, but then I know that here I have a lot of extra factors, so I will have to divide by them. 48 was the last number I used, so I'm going to divide by 47 factorials to get rid of the extra which I entered here. And of course, this 5 factorial stays here. So that's one way to write down the combination solution using factorials. Let's see, what else can you say? You can also say that this multiplication starts with the first number that was given to you and goes down to, you wanted 5 cards, and in order to have 5 factors, you have to subtract this and plus give back 1. This is going to be important because this will help us to understand the generalized form, and then you divided this by 5 factorial. Okay, so let's see how this looks like when instead of 5 and 52 we talk about picking K cards out of N cards. When we pick K cards out of N cards, then I will start with this form. From N cards, first one can be any of the N, then any of the N minus 1, any of the N minus 2, and I go down having all together K factors. So my last number to multiply is going to be N minus K plus 1, which was the number 58 there. And then I'm going to multiply this product by the possible ordering of my K elements, because I'm not interested in order, and that's going to be K factorial. That is called, there's a notation for this, but it's quite long, and we don't want to write it up all the time. That's called N choose K, which is quite a telling name in English, because you actually did that. You chose from N numbers, N objects, K objects. And in order to use this notation as well, which is actually a shorter way to write that up, you can also say that N choose K is N factorial divided by K factorial times N minus K factorial. Okay. So this is how you calculate combinations. Okay, let me illustrate, still using this card, some of the examples where combination is used. Let's start with something simple. I would like to distribute 6 cards now. So every player gets 6 cards. And the question is, how many ways can it happen? How many ways can you have 6 cards so that you have exactly 2 queens in the 6 cards? Okay, so what am I interested in? I'm interested in how many ways can I pick 2 queens. I have, as you remember, 4 suits, so that means I need from these 4 different queens 2. That can be done using notation 4 choose 2 ways. But since we are just beginning to use this symbol, let me explain what that means again. The first can be any of the queens. Let's say I pick the diamond queen, and the next card will be any of the remaining 3 queens. But in this, multiplication order is counted for, since diamond and then spade is also counted, and spade chose first and diamond queen chose second, also counted. So I divide it by 2. This is exactly what 4 choose 2 meant. Remember, 4 times 3 divided by the possible ordering, which is 2 factorial in this case. Okay, so I have my 2 queens, and I still have to choose 4 more cards to get the 6 cards. And these 4 more cards can be anything except the remaining queens, because I want exactly 2 queens, so I have to make sure that I don't by chance pick a third one. So I exclude the remaining 2 queens. That means I end up with 48 cards to choose from, and from those 48 cards I can choose any of the 4. So again, let me write down what that means. It means the first can be any of the 48, 47, 46, and finally choose from 45 cards. But if you leave it this way, then you ordered your cards, and you don't want to do that now. So you divide it by all possible orders. And this is your result. I know by heart that this is 4 choose 2 is 6, which is true. So this is 6. And this one, actually, I don't know how much it is, but I have good news for you. On your calculator, you are going to have a button which says N choose R instead of K. And this means exactly what it says. This helps you to calculate the N choose R value. So you just find this button, and this helps you to automatically calculate how much is 48 choose 4. Okay, let's see one more example. Let's say that in this case, again, you have 6 cards and you want to have exactly, no, you want to have at most, let's say you want to have at most 3 queens, still queens. Now, we have 2 options, as you probably all know by now. Either we calculate the good cases or we calculate the bad cases. The good cases involve no queens, 1 queen, 2 queen, or 3 queens. While the bad cases looks more promising because the bad case is actually one single case when you have exactly 4 queens. Basically, you got all the queens. So now that we established that, it's quite easy to finish the exercise because you want to have 6 cards, and out of these 6 cards, the bad cases are when you have 4 queens, and that can happen only so-called 4 choose 4 ways, which is 1. There's only one way you can choose from 4 cards. If you write it up, it's 4 factorial divided by 4 factorial, which is 1. And then the remaining cards come from the other non-queen 48 cards, and you have to choose 2 more. Remember, these were the bad cases, and you have 4 queens. And this one we can calculate. That was 1. And I can write up what this means. It means the multiplication and divided by the possible ordering. Let me put here factorial so we remember where this division by 2 comes from, which is actually then 24. And then this result is 24 times 47, which I'm not going to calculate now by head. And you have to subtract from all cases, these bad cases. All cases mean I want to choose 52, from 52 cards, 6 cards, which can be done this many ways, which again I'm going to write up for you. So this means multiplying 6 numbers in decreasing order. So your last number is going to be 47. So this is multiplication and dividing it by 6 factorial. And from this number, you have to subtract the bad cases. So your final solution is going to be, use your calculator to calculate these values, minus this one, which was 4 choose 4, which is 1, minus 48 choose 2. Right here, the correct answer. Okay, I hope these examples helped to clarify how to use combinations in card problems.